Hi and welcome back to Cog Vlog, this time representing Q400. Today's presentation is a study of the effects of combative drills on eye-hand coordination. The following exploratory experiment was conducted to give insight and direction into future research. The principle of my design was inspired by the work of Paul McCarthy at UCLA.
I've been focusing on how movement affects cognitive function.
After being exposed to this TED Talk on cognitive Kali by one of my martial arts instructors, Adam Rector, here at IU, I wanted to try it out for myself. The question that interested me was whether there might be a temporary boost to coordination after a short session of Kali practice. The participants were primarily fellow students at Indiana University. The methods involved administering 2 standard keyboard typing tests 10 minutes apart. During those 10 minutes, one group engaged in combative training while the control group sat or stood idle. The typing tests recorded the typist's speed and accuracy. However, the participants were not tested against any other tasks known or suspected to boost coordination. My motivation for this experiment is that I think cognitive science kicks ass. I've studied martial arts off and on for several years, and despite what some people think, martial arts are about more than just beating people up. There's an important philosophical aspect referring to a way, or do, that is to be followed through life. In modern experience, the term way or do refers to an art which is practiced for technical proficiency and spiritual growth. Such philosophical ideas are not always overt in the training, but there are always psychological effects that emerge over time. The long-term benefits of training can include improvements in concentration, discipline, self-confidence, responsibility, empathy, sociability, and coolness under pressure. More than anything, I'm attempting a sort of terminological revolution. In our fast-paced modern times, concepts such as spiritual tend to be expressed in categorical opposition to science. My overarching goal is to examine how concepts such as flow can be a vinculum between modern and traditional ideas of mindfulness. But, in order to prove it, we have to get out of the lab and the library and into the dojo, or vacant field, or parking lot, or, wherever there's room to swing a stick. But, as with all martial arts, proper footing is essential for technique. So, let's take a look at the relevant literature. Quoting an essay from Perspectives on the Coordination of Movement, edited by Stephen A. Wallace, we can ask, quote, why is it crucial to discover the principles of coordination among large numbers of interacting components? The answer is that this cooperative behavior lies at the root of understanding ourselves and the world we live in, how we touch, see, hear, plan, and act. Such fundamental behavioral functions depend on temporally coherent units distributed throughout different regions of the brain. Thus, we view the problems of coordination as continuous with efforts to understand pattern formation in complex systems with many interacting components, in particular synergetics, a theory of self-organization in non-equilibrium systems. The author of this particular text waxes almost poetical, saying, the two seemingly diametrically opposed views in science of surface simplicity arising from deep complexity and surface complexity arising from deep simplicity are both, in fact, part and parcel of nature's design for complex systems. And one of the most complex systems involves eye-hand coordination, or EHC. EHC is the ability to perform actions that require simultaneous use of the eyes, visual spatial perception, and hands to carry out a movement. EHC can work poorly even when the eyes and vision aren't affected and when motor control skills work properly. It is possible for someone with perfect vision to have eye-hand coordination problems that will only be apparent when they have to engage the visual and motor systems synergistically. So some of you might be wondering what is Kali and why did I choose it? Kali is a Filipino martial art that incorporates Eastern and Western forms of combat. It is similar to Eskrima and Arnis. These fighting systems developed under conditions of intermittent tribal warfare and are designed for speed and precision. The drills I had my subjects doing were used to condition practitioners to the movements and exchanges that occur most frequently on the battlefield. The two-handed mentality is to preserve combat readiness even after one limb has been incapacitated. I chose to study the effects of Kali on typing because both involve specific automatic motor processes utilizing both hands. This ambidextrous aspect was what caused me to consider keyboard typing as a possible measure of affected coordination. Typing requires automatic, fine-tuned motor functions and can, in conjunction with other tests, be used to identify neural deficits such as visual or muscular problems like strabismus, muscle hypotonia, balance problems, or cross-laterality. Brain damage to the motor areas or to perceptive areas may cause eye-hand coordination problems. One key idea, no pun intended, was that the Kali drills incorporated cross-body movements, and ought therefore to be more cognitively challenging than typing. There is reason to believe certain cognitive tasks can boost coordination for a short time after. These tasks include cross-lateralization or crossing the midline. When one crosses the midline, the brain begins to make new connections and the right-left hemispheres begin to work together. This communication process organizes the brain for better concentration and problem solving. Crossing the midline integrates brain hemispheres. When students perform cross-lateral activities, blood flow is increased in all parts of the brain, making it more alert and energized for stronger, more cohesive learning. Movements that cross the midline unify the cognitive and motor regions of the brain, the cerebellum, the basal ganglia, and corpus callosum, while stimulating the production of neurotrophins that increase the number of synaptic connections. In fact, according to Dr. Pam Schiller, former head of the Early Childhood Department at the University of Houston, crossing the midline is necessary for reading and writing, or typing, because to read and write, or type, one must work from one side of the page or screen to the other fluidly. But bear in mind, this primarily operates over numerous trials. I intentionally try to avoid participants who have previous weapons/combative training so that the Kali drills would require more focus and concentration than they would otherwise. It should be noted, however, that it is difficult to find any subjects without extensive typing experience. So in all fairness, you can ask, why did I choose typing? Copy typing, as in my test, is one branch of a complex skill tree that requires coordination of visual encoding and manual operations. The thing that makes typing stand out from other EHC tasks is its complexity and flow. The perceptual aspects necessitates the encoding of linguistic symbols as well as performance of all the fingers of both hands, which must carry out spatially calibrated and perfectly ordered movements for an extended period of time. Surprisingly, according to Albrecht Ehnhoff and Andrew Gordon of the Department of Psychology at State University of New York, despite the complexities of copy typing, the perceptual motor processes involved are relatively easy to study. As in Kali drills, typists plan sequences of manual movements at several levels, from identifying the target to responding appropriately. My principal interest was how typists must physically look ahead of their keystrokes to plan their movements efficiently, similarly to how Kali participants must read and adapt each other's movements. Because it's maybe not immediately clear how typing relates to coordination, I decided to contact human-computer interaction researchers through typingtest.com. I got in touch with doctoral candidate Anna Feit at Aalto University in Helsinki. She remarked that a typing test was interesting, but perhaps not the best measure for my study. She suggested it would be better to find tasks for which I can better attribute the performance changes to the factors I'm looking for, like increased concentration or coordination. Very likely that typing was too complex a task for this study. The data tends to be very noisy because typing skill varies a ton from person to person, and people have deficits at different stages of the typing process. For example, motor skill, memory of the keyboard layout, distractions, so on. Given the opportunity, I would divide the keyboarding test into more simple tasks to specifically test attention, working memory, and concentration, aka mindfulness. The subjects of my experiment were all volunteers. The participants were assigned to one of two groups. One group received 10 minutes of Kali instructions, and the other was left to pass the time as they saw fit. If the hypothesis that Kali training interacts with neurocognitive motor functions was correct, then the stimulus conditions ought to boost coordination as measured by the typing test. or if nothing else, finding any effect whatsoever could help inform future research possibility. The design consisted of, between subject trials, half the participants were exposed to Kali training. Originally, I planned to have the control group engage in light calisthenics and stretching. However, given the limited scope of the experiment, I felt it was better to allow the participants to pass the time more or less how they pleased, so long as they were not engaging in two-handed coordination drills of any sort. Therefore, the experiment was not to test the effects of Kali against other forms of activity per se, but to see if it would have an effect at all. Moreover, a valuable lesson I learned was that apparently nothing turns people off of volunteering like the words typing and exercise. So while I've began collecting and collating data, I don't have any results for you right now. So I know that's kind of anticlimactic, but let's skip ahead to the discussion. Obviously, there are serious flaws and limitations with this design. As both Paul McCarthy and David Landy, right there, pointed out, it is tough to control for any effect with only 10 minutes of training or whatever. And of course, my sample size is not huge, which will affect any significance. As stated earlier, the keyboarding test is likely suboptimal for measuring concentration/coordination. My only excuse is a lack of resources, time, space, subjects for my study. But on the bright side, I've gotten to interact with amazing people, and it's been a blast. My hope is that a sample this size can be useful for critiquing my hypothesis and improving my methodologies. My ambition was to show that a traditional fighting system may have benefits for a highly technical society. That is, in an era of overall increasing peacefulness, I wanted to show that the Do, or martial way, was still relevant and founded on sound cognitive principles. I'm very excited about the possibilities for cognitive Kali, and I look forward to studying it with more depth and thoroughness. So for the time being, keep fighting the good fight, and thanks for watching. By the way, I don't actually wear glasses, I just didn't want anyone to hit me.
Hey there.
There's an important philosophical aspect